Hey there, CS210 students. So in this recording, we're going to introduce pointers and how they are useful in C++. So they start off here in section 1 with a really good use case of why pointers are so powerful. So we have used vectors in our class. And so the idea of a vector, we've got a vector of type int. So you should know that this vector lets us save values. We've got the values 9, 1, 6, 8, 3. And what happens is when we declare this vector and we insert into the vector, we are placing them in contiguous memory locations. So the advantage of the vector is that it knows that the values are coming one after another. It knows exactly where they are. Well, the issue with that is, what if you want to keep, say, this vector in order, or you want to insert a value inside this in a particular location? So if I want this vector to be sorted, I'd have to go find where I insert the value. And even if I'm just inserting, I have to go find where I'm inserting, and then what I'd have to do is copy over everything to the end after I've done my insertion. So that copying over is a lot of overhead. So they go through the details talking about that. So if I'm going to insert or erase in a vector, erasing isn't so bad. Well, no, I guess it is bad because I have to move everything again. So inserting in the vector or erase in a vector, a lot of overhead when you have to shift all of those values back over. Well, the linked list, what it does is it is still a sequence of values, so I still have values that I have, but with the linked list, it maintains a reference to the next value. So in a linked list, if I want to insert something, it's very simple. I find where I put it, and then I reset the link to the next item. So they go through the details talking about that. You'll actually implement it in the lab. In the big scheme of things, I want you to, just get this functional. Go find a resource or reference if you need to. Just document it in the lab. Nobody implements their own linked list. They use a library implementation. So they're going to have you manually create it, but for our purposes, just make sure you get it done. Anyways, back to what this is all about. The idea of the pointer is a linked list uses a pointer to the next element. So that makes it very quickly in order to insert values. And okay, so now let's go into section 2. All right, so let's formalize the idea of a pointer. We saw a use case of it, but now let's formalize what a pointer is. So a pointer is a variable. So first off the bat, keep in mind that it's a variable, but it's a different type of variable where it holds a memory address, unlike most variables which hold the data. So they have a nice little example down here. So here, just like you've been doing all term long, you declare a variable, and so you give it a data type. So what happens is that the compiler goes off and it sets out a memory block. So right here is a memory block for some int. So it's in memory space number 76. And at some point, it's going to be assigned the value of 5. And so that some int references this value 5. Every time I use some int, so when I use some int, it's going to give me back the number 5. Well, a pointer, again, is a memory address. So down here, they're declaring a pointer variable. So the syntax is a little bit different. You still have to specify the data type. And then we use the star notation to say that this is a pointer. This is the preferred method of declaring a pointer variable for my opinion. So I know that's an int pointer, and then it has some variable name associated with it. So what this does is, again, it goes off, and this val pointer gets a memory address associated with it. So each and every time I assign to it, so we are assigning to val pointer right here, we have to get a memory address. In order to do that, you have to use the reference operator or the ampersand. So here we have a variable that's been declared, some int. When I use the reference operator, this gives me back the memory address for some int. Well, where is some int's memory address? It's 76. So val pointer contains the value 76. So in this example here, when we come out here and print out some int's address, so when we use the reference operator, we're going to get 76. And then when we print out val pointer, remember it's a memory address location, it's going to be the exact same thing here. Now, oh, by the way, if you were to run this in your own computer, you are not going to get things like 76. You're not going to get nice numbers. You're going to get it in a hexadecimal form, but it would be the exact same. And again, they point that out right here. So they're going to print out some kind of hexadecimal form. They're just using a nice, simple way to understand the value. Okay, so with pointers, what we have is a memory location that we can refer to. So if I want to get the value contained by the pointer, then we have to dereference the pointer. So to dereference a pointer, we use the star symbol in front, and that's going to give us what is contained in that memory location. So same situation we had before, we're going to declare an integer variable, an integer pointer. We assign 5 to the variable some int. Now we're going to have our pointer get the memory address of some int. So this code right here is all the same as what it was before. So when we print out the some address reference location, when we point out the pointer's memory address, they're going to be the exact same right here. But now take a look what we can do. We can dereference what the pointer is pointing at, and they're reassigning that to contain a 10. So when I dereference, I'm actually going to the memory block, and this was originally a 5, and now we're going to override that 5 and put in 10. So now when we come out here and print out what some int is, it now has 10. And if I dereference what the value contains, it's also, excuse me, when I dereference what the memory address contains, it also has a 10. So I know that this can get a little confusing for you. Always keep in mind that a pointer points to a memory address, and 90% of the time, you're not going to be printing out the memory address. You're not going to be manipulating the memory address. You want to manipulate what the value that it contains is. So to manipulate the value that it contains, you have to dereference it. You have to use the star out in front. Another thing is that you can use a null pointer. So we can declare our pointer variable. We can assign it null pointer, which gives us a nice way to check if it has not been initialized and then properly handle it. Otherwise, we can dereference it if it's a null pointer. Just like in other programming languages like Java, if you try to reference something that has not been initialized, it throws a null pointer exception. Same idea is going to happen here. So we can assign it null pointer, and we can check if it is indeed a null pointer. Okay, some common pointer errors. So a common error is to use the dereference operator when initializing a pointer. So we have dereferencing here. So we're going to try to dereference a variable and assign it an memory address. So this is a syntax error because this is referring to the value, not to the pointer. So remember, when you're dereferencing, you're always going to give it a value. You're not going to give it a memory address. Another one that's very common, and this is a big no-no that can be easily fixed by never, ever, ever declaring multiple variables on the same line. This is one of the reasons why I put it in the coding guidelines. When I do this right here, this starts out saying that everything in this line is going to be an integer, and then this first one is going to be a pointer. This second one is not a pointer, it's an int variable. So good practice is to declare one variable per line. It shouldn't just be pointer, but it should be one variable per line. And then you don't ever have to worry about the fact that the first one's a pointer and the second one is actually going to be an integer value. And again, they talk about declaration styles. My preferred syntax is this right here. So I want to say int pointer. I want to read it left to right. And again, only one variable on a line, and I can see that it is an int pointer. Okay, so now that we have the idea of what a pointer is, here's why it is very useful in C++. We can now create variables that are pointer types, and the pointer type is going to be much faster access to memory information than if we don't use pointers. Okay, so that's one of the reasons why C++ is a very fast language. So in order to use the pointer, we have to use the new keyword. So I know all of you have had the Java class. So in Java, C#, programming languages of that type, you're already used to using the new keyword when you create a new reference. So in C++, that new keyword, it actually returns a pointer to the memory that was allocated. Okay. So let's see what that means in action. So we have a class called point, has a constructor, doesn't do anything. Nope, sorry, it sets them both to zeros. And then we have some public variables x and y. They didn't provide getters for these because we're just going to access them within the code here. So they implement the constructor in the main method. We're going to create a variable using the new keyword. So when you use the new keyword, it has to be declared as a pointer. So just to make sure that we understand that, let's just come in here. Let's copy and paste this. So we've got the point class in here. So if I just try to do point sample equals new point, we have a syntax error and it says no suitable constructor exists to convert from point star, which is a pointer, to point. So this has to be a pointer variable. Let's just do a little work here. So sample.x. So let's print out what our sample x is. And one thing I want you to notice is in Visual Studio, I hit the dot operator. And after I hit the dot operator and moved on, it automatically turned it into the arrow operator. So when I'm referring to a pointer, I have to use the arrow operator. If it's not a pointer, then I use the dot operator. So real quick, let's print out x and y here. So sample.y. Again, it automatically puts the arrow operator there. So great, we get 0 and 0, fantastic. So some other things that I want to show you here. So we saw with the integer values that we could dereference and get the value. We can do the same thing here. So I can dereference my pointer. So this is dereferencing the pointer. Note that I have to put it in parentheses. And now take a look here. I use the dot operator and I have access to x. So this is using the pointer. This is using the actual value contained there. So same deal. I can get the y value. And I can print those out. So when I run this, both of these work the exact same way. I get zeros printed out just like I was supposed to. Keep in mind that always using the pointer is going to be the faster method, okay? So using a pointer is always, always, always faster because you have access to a particular type of memory. We'll talk about that here in a future section. All right, so continuing on. So we just talked about the new keyword. So This creates a pointer. They continue on. They talk about that we could provide constructor values. So then when we use our new keyword, we have to use the constructor. And then you can see here that they just talked about the fact that if I want to, I can use either the arrow operator or to dereference it and access it that way. So that's the member access operator, the arrow. Again, we've already kind of covered that. So always remember, use that with a pointer, and then you have to use the dot operator if you are dereferencing what it contains. All right, next thing that is a big idea with C++ is the fact that when I use the new keyword, I am allocating memory myself. So one thing that makes C++ a very powerful language is that you, the developer, have control over the memory allocation, unlike other languages like Java, C#, and so forth. But with that comes consequences. So when I use the new keyword, if I don't ever delete this pointer, then this exists forever and ever. And we'll talk a little bit more in details about that. But what we can do is we can use the delete operator. So I come down here and say delete point 1. And if I try to reference point 1, if I try to do it, I'm going to get an error because we've deleted that particular pointer. Okay. So again, the idea with C++ is when you use the new keyword, you have to manually manage that memory yourself. Next thing about pointers, let me jump back here. Hold on one second. Was it in 10.2 where they declared arrays? Okay, so we can use the new keyword to declare arrays. Sorry, we can use the new keyword to declare an array. And remember, every time you use the new keyword, you get back a pointer. So with arrays in C++, what this pointer actually points to is the very first memory location that was assigned. So that would point to the very first memory location. And then it makes it very powerful when I loop through my array. So you can see many points is the array. Right here, they're going to access the array using the bracket notation I. And this is going to increment where we are in the array. So we can use a pointer and move to the next entry in the array using pointers in C++. Pretty powerful idea. Now, when we do this delete down here, this will delete our reference to many points. Okay, so let's move on to section 6. So let's talk about where memory gets placed in an application in C++. So we have two different types of memory. We have the stack, we have the heap. So stack is usually for local variables when they are declared during a function call. This memory is called automatic memory, and the memory is allocated and deallocated as needed. The heap is anytime you use the new keyword. Now, the difference between these is that the heap provides very quick access to the information. The stack is going to be a little bit slower. So ideally, we want to have things on the heap so we can get the fastest access to them. But by placing it on the heap, the new keyword using there, we have to manage that memory ourselves. So they come down here and they give some examples. So right here, when we declare an integer variable, so this is outside of a function call. This is in static memory. They're allocated once and they stay in the same memory location for the program's entirety. Here, they're declaring a variable inside a function. It's going to be placed on the stack. That memory can be reconsumed. The heap, when I declare a pointer, when I use the new keyword and declare a pointer, it's going to be allocated on the heap. When I use the delete, that will deallocate it from the heap, and now I can reclaim this memory right here. So make sure you know the differences. Stack versus heap. Heap is anytime you use the new keyword. Now, there's a consequence to that using the new keyword. We can run into what's called a memory leak, where a program is allocating memory along the way, and it doesn't have access to that allocated memory. And it's typically due to not properly destroying or freeing the dynamically allocated memory. So as you run an application long enough, for instance, Chrome is notoriously known for having memory leaks. I guess I'm in Edge right here. But Chrome notoriously has a lot of memory leaks, where the longer and longer you use it, the more memory, the more RAM that it's going to consume. So to handle a memory leak, we have a couple things we need to do. We need to make sure that we are freeing our memory in a destructor. So we've talked about a constructor in our class. The destructor is the reverse. That's going to use the delete keyword properly, making sure that the memory that was allocated gets deleted. So you can see down here that they have a class variable. They have a class down here, and they come down here, they create an instance of new class. They try to use the delete keyword, but while this would free out the object's memory, this doesn't free out what's inside the actual object. This would create a memory leak. So let's take a very close look at the inner workings of this class. So it has a pointer to an int right here. So when I delete out my temp class object, I haven't deleted out this pointer right here. This would have been created and initialized. We never freed this right here. So we're going to need a destructor that handles the inner parts of our class as well. And so we get that in section 8. So the destructor, again, is very similar to the constructor, except in this case, we're going to tear apart our object. So the destructor uses the tilde symbol here. And inside the destructor, here they're just printing out that we're inside the destructor. I think they've got an actual concrete implementation. Yeah, right here. So in a concrete implementation, what we want to do is we need to delete any of the inner variables that are contained using the new keyword. Otherwise, if we don't, we'll have created a memory leak. Now, I know that's a ton of information to throw at you. For our purposes right now, I want you to be able to create a pointer variable. Know that if it's a pointer, you have to use the arrow operator. If you have a pointer and you want to dereference it, so in this case, maybe you wanted to assign a value to this, then you would use the dereferencing operation. Okay, so I'm gonna head out from there. There's gonna be a part 2 that talks about some of the other concepts, but this is the very beginning. All right, as always, reach out if you have any questions.